Based on the concepts whatever we have learned so far, let us solve few questions from the percentages. Now very first question goes like this. There is a town whose population is 20,000. Now it is increased by 10%, 20% and then decreased by 30% in 3 years. Now we need to find out what is the population of the town after 3 years. Well, there are multiple ways of solving this. Let me give you a couple of methods. So originally, we shall apply the successive percentage what we have learned already. Now 20,000 increased by 10% in the first year. Now we know 10% of 20,000 is 2,000. Now, if it is increased by 2,000, the population would be 22,000. Now again, in the second year, this population is increased by 20%. Now, 10% of 22,000 is 2,200. 20% will be double that value, which will be 4,400. Now, population increased by 4,400. 22,000 plus 4,400 should give us 26,400. Now, again, this population is reduced by 30% in the third year. Careful, it has reduced now. So we need to calculate what is 30% of 26,400. We know 10% is 2640. If you multiply that with 3, we should get 30%. That should give us 6,000, 7,800, 7,920. So if I subtract that 7,920 from this, we should get the population after 3 years. Now, better way of subtracting, do not subtract 7,920, rather directly subtract 8,000 from this value. If you subtract 8,000 from 26,400, you should get 18,400. But you have subtracted 80 extra, added back. So you should get 18,480, and that must be our final answer. Well, this is a very direct way of solving where there are complicated calculations. But let me show you a better way of solving in the same method. Now we know original population is 20,000. Rather than applying the 10%, first I would like to apply 30%. So 30% decrease. We know 10% of 20,000 is 2,000. 30% will be 6,000. So let us decrease it by 6,000. What should we get? We should get exactly 14,000. Now again, let us apply 20% now. If I increase it by 20%, we know 10% of 14,000 is 1,400. Then 20% will be 2,800. But this is increase, careful. Now if I increase it by 2,800, I should get 16,800. And finally we are left with one last percentage, that is 10%. Let us apply that as well. Now if I apply 10% of 16,800, that is 1680. Now if I add 1680 to this, that will be 17,000, 18,480. Now this is the same as the previous answer. Well, what is the difference? If you see, the calculations in the previous part were slightly complicated, whereas here the calculations were pretty smooth. What is happening here? If you see here in the last step of the first method, we are calculating the 30% of 26,400, which is very complicated when compared to 30% of 20,000. So I think you must be understanding the trick here. The trick is pretty simple. Always first apply the complicated percentages and then keep the simpler percentages for the end, because as you keep on continuing, you will be getting a complicated numbers at the end. So for them, keep the percentages simpler. That will definitely work for us. Well, there is another way of solving the same question, provided you're good with multiplication and the cancellation. Let me show that to you. Now we know the original population is 20,000. Well, when this is increased by 10%, it means 10% more than the current population. Now that becomes 110% of 20,000, that is in the first year. Now in the second year, again it increases by 20%. It means this whole value is increased by 20%. So the new population will be 120% of this entire value. Again, in the third year, population reduced by 30%. It means this whole value is reduced by 30%. So we will be left with 70% of this population. Now, even if you solve this particular equation, you should get the same answer. Let's check it out. 70% can be written as 70 by 100. Of is nothing but multiplication. 120% is 120 by 100 into 110 by 100 of 20,000. Now, let us go with the cancellation part here. If you see, there are two zeros. I can cancel them with this 100. I can cancel these two zeros with this 100. Again, these two zeros with this 100. And we have final multiplication part. What we have here is, so 12 into 7, which is 84, into 2. 84 into 2 is 168. That should be multiplied with 11. Final step, this one. And there is a 0 at the end. If you multiply this, we should get 8, 4, and then 7, plus 1, 8, and then 1, and there is a 0. 18, 480, which is absolutely same as previous answer. Our second example is just a modification of the first example. Let me give the question to you. The question goes something like this. In a town, the population increases by 10% and 20%, and then decreases by 30% in 3 years. Now, after 3 years, if population is 18,480, what was the population 3 years ago? Well, if you observe that, this is absolutely same as previous question, but in a reverse order. Now, what do? Can we reverse engineer it? No, because we have already seen that reverse engineering does not work in percentages. So what we can do? We know that population after 3 years is 18,480. But do we know what is the original population? No. Let us consider it as P. Now, after first year, in the first year, the population increases by 10%. Means after 1 year, the population will be 10% more than P, which should be equal to 110% of P. Now, in the second year, population again increases by 20%. It means after second year, population will be 20% more than this population. So the new population is 120% of this population. Again, in the third year, population decreases by 30%. It means the population after 3 years should be 30% less than this population. So it should become 70% of this overall population. Now, if you observe, this entire value should represent the population of the town after 3 years, which must be equal to 18,480, because according to the question, this is the population after 3 years. But as per our equation, this is the population after 3 years, and both are same. It means we have to equate both the populations. So if you go with the calculations, we should get 70% as a 70 by 100 into 120% is 120 by 100 into 110% is 110 by 100 of P should be equal to 18,480. Now what will I do here? I'll cancel this 0 and this 0. Please be careful with the cancellation. We have 11 here. When I cancel this with the 11, 11 ones 11, 74 is left out, 11 6 is 66, 8 is left out, 11 8 is 88. Now again, I'll remove these two zeros with this 100. I have 12 here. If I cancel this with the 12, 12 ones is 12, 4 is left out, 12 fours or 12 threes, 12 fours is 48. Now if I take 7 again, 7 ones, 7 twos. Now, we don't have anything in the numerator, we are left with P. In the denominator, we have 200s, which is nothing but 10,000. If I multiply this 10,000 with the 2 this side, so P should be equal to 2 into 10,000, which is same as a 20,000. That should be the original population of the town 3 years ago. Now this is same as our previous question. I just reversed the question and give it to you. A third example goes something like this. Let us say there is a rectangle. Now I say the length of a rectangle is increased by 20% and the breadth is increased by 10%. What is the percentage change in area? Well, I did not give you what is our length or what is our breadth. Can we do that? Yes, of course. We can assume any value. So let's say our length is 20 and our breadth is 10. Now according to the question, length increases by 20% and breadth increases by 10%, right? And we need to calculate the percentage change in area. Now, when length increases by 20%, original length is 20, it is increased by 20%, 10% of it is 2 and 20% is 4. Then the new length will be 4 more than this, which is 24. Let's call it as L dash. And let's call this as L and let's call this as B. Now, a breadth is increased by 10%. Original breadth is a 10. This is increased by 10%. 10% of 10 is 1. And 1 more than 10 means our new breadth should be equal to 11. Right? Now, originally our area of rectangle is calculated as a length into breadth. So, original area, length is 20, breadth is 10. 20 into 10, 200 square units. Now the new area, after the increase in the length and breadth, length is 24 and breadth is 11. If you multiply both of them, we should get 220 plus 44, that is 264. 24 into 11 should give us 264. This is the new area. But what do we want? Percentage change in the area. How do we calculate percentage change? Change in the value divided by original value into 100. So what is the original value here? 200. Final value is 264. Change is 64 out of original value or original area, which is 200 into 100. This should give us the percentage change in the area. So 00, 00, 2 into 1, 2 into 32. So overall percentage change in the area is 32% increase. Well, that was a very conventional way of solving. Now let us try to put a concept inside this. You know the length is increased by 20%. Now observe carefully. When length increases by 20%, what else increased in this figure? Obviously, area also increased there. Yes. Now again, breadth increased by 10%. It means again area will increase. So what is happening? Whenever I increase length, area increases. Whenever I increase breadth, area again increases. It means when I say length and breadth are increased by 20% and 10%, it also means area itself is increased by 20% and 10%. So we got to know one variable is increased by 20% and 10%. This is absolutely same as our successive percentage. So we know that formula for successive percentage is x plus y plus xy by 100. This will give the percentage change in successive percentage. Our x value is 20 and y value is 10. So x value we shall put as 20 and y value as a 10 plus 20 into 10, x into y, that is 200 divided by 100 should give us 2. So what do we get? 20 plus 10, 30 plus 2 is 32. Now positive value represents 32% increase. So if you observe this, within a fraction of seconds we can get the answer if you know the question is based on successive percentage. Well, how do you identify whether the problem is based on successive percentage or not? It's a simple trick that if any variable is a product of two other variables, that should always work with successive percentage. Like here we had area is equals to length into breadth, or I can have distance equal to speed into time, or force is equals to mass into acceleration. Now what if I give this area is equals to pi r square, that is area of circle. Is this successive percentage? Let's check that as well. What is the percentage change in area if a radius of a circle is increased by 10%? Well, we have a circle whose radius is increased by 10% and we need to calculate percentage change. Now observe, we know that area of circle is equals to pi r square, where pi is the constant which will never change. So we need not to modify that. So we can write area is equals to, or area is proportional to r into r. So when area is increased by 10%, here this r also increases by 10%. Again this r also increases by 10%. So what is happening here? When you increase the radius one time, area increases two times. So again, even this will fall under our successive percentage. How? If area increases by 10%, radius increases by 10%, area increased by 10% and again 10%. So by applying the x plus y plus xy by 100, x value is 10, y value is also 10. So x plus y is a 10 plus 10 plus x into y, which is 10 into 10 divided by 100. So 100 by 100 is 1. Altogether we should get 21% increase in the area. Now what happens if I tell side of a cube is increased by 10%? And what is the percentage change in volume of the cube? Now observe, we know volume of the cube is side into side into side. Okay, so if one side increases by 10%, this will increase by 10%, this will increase by 10%, and this will also increase by 10%. It means area of the cube will increase by 3 times, that is 10%, 10%, and again 10%. So let us see what happens. Now can we apply x plus y plus xy by 100? Of course you can apply. We have 10% increase, a 10% increase and 10% increase. So that is, if we apply for 10% and 10%, x plus y plus xy by 100, we will get the same answer, that is 21%. Again we have another 10% here. For these two, if we apply x plus y plus xy by 100, we should get 21 plus 10 plus 21 into 10 is 210 divided by 100 should be 2.1. So that is 21 plus 10, 31 plus 2.1, that is 33.1% increase. So when you increase the side of a cube by 10%, volume increases by 33.1%, and that has to be our final answer. Now observe, be it a rectangular figure or a circle or a cube, whichever it is, any geometrical figure, whenever one variable is a product of 2 or more variables, obviously you can apply successive percentages in those problems. To watch more free videos, download our LOL application from Play Stores. If you are benefited by these videos, please like and share our videos, and also do not forget to subscribe to our YouTube channel so that you don't miss any of our new videos that we upload regularly. If you have any queries or suggestions, please drop them in the comment section below. Also, if you want to reach out to me or any of my team members, you can always do that through any of the social media platforms, and the links of which are already provided in the description below.